All right, so I'm live with data science projects with Rust. And what's going to be unique about this is I'm going to focus more on command line tool oriented data science projects. So let's go ahead and present our screen here. Let's get right into it. And so I have this repo here where I've been working on a lot of stuff in Rust MLOps template here. And I think what I'll do is I'll build out a command line based data science project inside of this template. So I'm going to go ahead and launch this code space here, kick it off. And what we can do inside of this environment is get started with building a command line tool based approach to data science. And so what I'll first do is make a terminal, get this thing cooking. And what I'll do is just say cargo new, we'll call this DS data science CLI, right? And I'll CD into this project. Now the next thing that I'm going to do here is pull it up. So we'll go through here, DS CLI. Now I do like the makefile approach, which is really helpful to me because it fits with the way I think. And I just had one here, so I'll just basically copy this into my local directory and just tweak a little bit. We'll say cp web docker makefile dot. Okay, now I can go into dscli here and just take a couple things out. We don't need this stuff. The rest of it, I don't need that. I just need basically format lint and that stuff. And so I also want to make a really simple lib. We'll say source lib.rs. Here we go. So we have a lib and a main. And I also want to install the command line tool things. And so I can just look at other project here and just copy something. Here we go. We got that. And so if I go back to this project, we can put that in. So this is really the trick, is scaffolding that I like to set up, like makefile, set up, command line tool. And what it would be kind of fun to do in terms of a data science project is to see how to build a command line iterative data science project. And I'm going to start with just the command line tool stuff first. But what I was looking at before was life expectancy data. And I'm going to go with that still. And so if I go here and I go to lib, we can say basically a library that provides an interface to this. We examine life expectancy. Sure, let's do that. So from places that are easy to consume in Rust. How about that? So the first thing is, how can we build out something that pulls the an API that we can listen to? And so where could we get some life expectancy data? I think I have something here. If I look at polars, yeah, we have polars df. Let's look what I did before. So utilities for working with polars data frames. And then I had a main file here. So I guess what I did before was I did have some data here that I could do something similar. Basically, I could use polars, and let's try that. Let's kind of use the same concept. And so what I can do is I can go back to here, and we can also go to our cargo file, and we can import polars. Now, let me look at how I did it before in this other project. let me look at the cargo file. So yeah, polars, we'll go through here. So this is the data frame. It's essentially pandas, but for REST. And I put this const file. So I need to make a data directory, data, and then I can just copy that file into here. So I can say cp up a directory to polarsdf data, source data, and then global life expectancy, and put that into source. That looks good. Source data. No, we need to put that into, we want to put it into data. So we want to move it into that. Yes, there we go. So we got that in there. And now what I can do is basically look again at my other example here and just see if I did anything cool. So what do we have? Print number of rows, print the schema, print the shape, use polars. So that looks like probably something we would care about. So we would put this right here. Library that provides that introspects global life expectancy data using polars. Okay, so we got that. So I guess the first thing would be to, sure, let's read in a CSV file. So we'll go ahead and do that. And I could actually we could say prints, but we could pull this, put the data into a data frame. Okay. And then we would say prints in rows of the data frame. Looks good. So these all look like things I could build out into a command line tool. So let's go ahead and go to the main file here. And we can, again, kind of copy our other project here and say something like this might be good. We can tweak it a little bit, but let's go to here and let's go to main and let's just print this out. So we can say basically command line tool. Okay, so command line tool. So we'll call this life expectancy exploration. So life expectancy CLI that uses polars and clap. Okay, so we got that. That looks good. We don't need polars here because we already imported it in the library. We don't need that const because we already had that. And we could just say a data science CLI that uses polars and clap. And example would be, sure, let's start with that. Prints, this looks pretty good. Path. Now, the default value, we don't even need the default value because we want to do this. We want to say default value is CSV file. Is that what it is? Yeah, CSV file. And then let's try this out. So we can say format. Do make lint. Let's see if this works. So the idea here is that this main file, again, will map directly into each of these functions, right? We'll pull those in, and here we go. We can say that consider importing this constant. Okay, sure, let's try it out. So I'm learning more about the proper way to build stuff. Let's go ahead and do that. Okay, now let df not found in scope 34. So this is because we exactly we want to do that. And then remove the extra arguments. That's in lib14. Put the data frame. Remove the extra argument. So it says this function takes 0 arguments. Oh, I see. Well, we need to fix that. That's bad code. So we need to say basically CSV data into data frame by accepting path. Okay. So this would be path, and we can do this stir. It looks good. Let's do a lint and unnecessary let. Oh, so we just do read CSV. Is that it? And then get df expected. Oh, expected returns data frame. So this would be let CSV equals that, and then let what we need to do is put this and then use CSV to create a data frame at df. Let's do that. That. Expected. And we'll call this let df equals f. How about that? Arguments to this function are incorrect. Expected struct, but found. Yeah, so maybe I don't even need this. Maybe I don't even. Let's look at my other code here, and let's see what I did previously. Was CSV reader, print the shape. So read in CSV, CS reader, and returns a data frame. Well, why reinvent the wheel? Why don't I just take something I know works, and I'll just put these two, replace what I was writing, because these were a mess. There we go. So path. There we go. Let's try this. And previous definition of df, so line 19. So this, we don't need that. Yeah, we just need these two. It's just format, make lint, and not found get df, because we can just say printdf. In fact, we don't, yeah, we can really clean this up, because we can say let df. We don't need that. We just df. Oh, it takes a data frame and this returns a data frame. So I guess we do need that. So yeah, we do need that. Let's make format. There we go. So that did work. So now we can say cargo run dash 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 help, and we should get this thing cooking. Now, what will be kind of fun is to see if I can get a really quick k-means cluster working. That would be an improvement over some stuff I've been working on in the past. Okay, 181, 183, 182. Let's see if this can work. Nice. Now if I go to prints, something got screwed up. It says no such file or directory. So I think the issue is maybe this. Let's double check here. And if I say /L, oh, well that's could definitely be the problem. Oh, because I need to MV data to source. Well, now, there we go. So now if I go through here, boom, life expectancy, pretty awesome. So what would be really cool is, can I do k-means clustering? Because I got that working, but can I do k-means clustering? So how would I do that? So let's go to k-means Rust, and there's like a linfa. What is this? A small library for doing k-means, centroids. I mean, k-means is trivial. I mean, I could write it myself from scratch, but k-means Rust polars, although I don't need it. What's this? Linfa. Let's try linfa. I've heard of it. Let's try it. So we'll say linfa k-means. And I think it's better for me to go to this repo real quick. Let's just try real quick. Let's just go to linfa here. And let's look at clustering. Linfa clustering. So we have k-means. So cargo. I'm gonna go to the crates here real quick. I'm gonna go to crates and I'm going to type in linfa k-means, k-means, linfa, linfa clustering. So there we go, blah, 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 blah. So let's copy that and let's go to this. And then what do we need to do? Let's go back here. So please show me a really quick example. Docs. We want to do k-means. So linfa clustering. Let's try that. So we can do this. And we can just do a make lint real quick, just see what happens. Hopefully it's able to get k-means in here. Okay, well that's fine because we haven't used it yet. And then we can say do clustering on. Now, I'm curious about if I just do prints time here is what are the fields? So we could let's take a look at the what k-means data we've got. K-means. Okay, so what do we got here? We have two. I mean, this would be interesting. What if I did 2018, 19, 20, and I clustered on that, and we just see who is similar amongst those 3 years. I like that. So of 2018, 19, and 20 in the data frame. Okay. So we're going to say pub fn function. We're going to say, how about cluster, right? And what can we do here? We can go back to the docs. We can say, okay, database. Let model, I think is what we need. So we want to say, hopefully, I think the issue with this would be we want to give it the data frame, so it will need that, and then what it should return is potentially do k-means of this, and we can say return. We can just say prints cluster, prints the cluster, prints the countries, counts of each cluster. Yeah, print the count of each cluster. Or no, we'll just say this, returns a data frame with cluster membership. Returns the data frame with the cluster column added. That's what we need. Okay, so this is looking good here. So hopefully Copilot will be our friend and help us out. So we can say it's going to return a data frame, a mutated data frame. What we got? So clone it. You use these 3 parameters. Predicted. Did I get lucky here? Let's see here. Extract, fit. Let's see. Say make int. Come on. Uh-oh. Not surprised that we had some issues. Make format. Okay. Now let's look again. Got so unused import params. Okay, yeah. So that's good. Those aren't hard to fix. Unused imports, which are good. I'm glad. I want the compiler to tell me that. So let's do it again. Oh, much less. Just do no method name fit. Method not found. Let's look at the way they do fit. Let model equals k-means. So we got to just guide it a little bit. So let fit, let model equals, and let's see how they do it here. Let models params with random. Once we found it, to fit observations. Now, I'm going to have to look at the code here real quick. Let's look at the examples, k-means. So params with. So we want something. What is this one? Distance. Okay, let's go here. There we go. And let's do something like this. Params with. It's going to look kind of like this. So let model params with. So something like this. And let's see, number of clusters. We're going to say 3. Okay, let's. Okay, kind of hard to understand, but let's do this. Let's just say, let clusters equal, let cluster count equal. Let's make this kind of at least readable code here, because that's going to be tough for people to read. Less cluster count, and then for RNG and let's see what else we need to do here. Okay, map selects clusters predict, add this column, and then return the data frame, which is what I'm hoping. So let's see if this fixed it. Same map. Okay, and ooh, let's see, a lot of errors now. So failed to resolve linfa in. Oh, linfa in. So how do I import that thing? Let's go back to our code here. Linfa in. Oh. Let's import that. Lympha in. Oh no, that's the wrong one. This one. Lympha in. Lympha in. Lympha in. Version is lympha in. How do you get lympha in? That's a good question. Lympha crates. That's weird how it didn't pick that up. Let's throw this in here. Okay. So next up, what do we got? Use of undeclared. No, I think I already fixed that. No, this is the next one. So we want, use of undeclared rand. Okay, so we also want to do rand. So rand. Okay, so we'll just clear a bunch. Clear. And then now let's do maintenance. And we'll go to no fit found. Use this. Okay, let's go to here and let's do that. Where's my lint? It's kind of hard. This is one thing that's kind of annoying with the lint. I'm gonna have to do like a less, just so I don't get kind of overwhelmed with the linter. But so here we go. Failed to use of undeclared rate. Use of undeclared rate or lympha traits. Use traits. Lympha traits, maybe? Use. Let's do that. Lympha traits. Huh. But the namespace with this particular library is not great. But let's see. Okay, so let's see if that fixed it. And mismatched type. Arguments to this function are incorrect. Expected use size. So 28. At least that's a little bit easier to deal with. So 28 expected use size found integer for and. So we'll say here convert integers, cluster integers to use size. We can say new let clusters or let array well, let cluster array or something like that. How about cluster array? And then we should be able to do like that. Then if we go back to this, you can say fit, and it would be cluster pass in array fit. Let's see. Let cluster array selects. No, it would be. It would not be this. Not fit. It would be this. Just be that. Why is it giving me wacky code? So expected structs found a polar series. So the data frame now would need to be fixed. So convert data frame to database. But this is probably the part that will be a little bit tricky to get totally right here. So I'm just going to call it that it's close, but I'm gonna say TBD, right? Because I think this would be a little much for me to finish. Say like we'll say TBD, TBD. But I'm curious though. I think I'm on the right track here. So I just need to nuke this stuff. Go back to cargo, get rid of this stuff, and so what I'll do is I'll just make a like some notes here. So we can just do. Let's just make sure everything compiles. Make sure it lints. Okay, so I'm gonna just add some notes that say as a next step, next time I work on this project, let's do this. We'll say command line data science Rust next steps action items. Very action items. So we need to figure out. So this is the repo. So one, go into this repo and then figure out a way to make polars work with linfa. Now, if it's a big pain in the butt, what I might just do is just write k-means myself, right? Because it isn't a complex algorithm. So we need to figure out like how can I make a k-means cluster using polars, and I think this should not be too bad. So there's going to be some cutting edge things here, but it's actually kind of exciting. I wouldn't mind writing my own k-means cluster, or I use another library. But this is a time like an action item for next time. So I'm going to say get status. I have a working tool. That's the main thing, and we'll go from there. So go ahead and commit this, adding working polars command line tool. Okay, let's do a get pull, and let's push this code here. Get pull, merge it, get push. All right, see ya for this series in a couple weeks.